Hello everyone, this video is talking about ATM and PRS interserve and diffserve. In first part, the following 5 key points would be introduced about ATM. A synchronous transfer mode is a switching technique used by telecommunication networks that use a synchronized time division multiplexing to encode data into small fixed-size cells. The label switching is labels of fixed-length stack state is switches that indicates how to switch packet, and the benefits are simplified core networks, traffic management, provide new service, and it can use both in ATM and IPRS. The short fixed size packets can carry information through the night, sometimes called fast packet switching. The reasons for fixed size are switch design speed, simplicity, concurrency, and the reasons for size being short is minimizing synchronization delays for sensitive traffic. Based on the picture, we can see that if copying with a fixed size is too small, the too much overhead per byte of payload will happen. But if it's too big, it will waste when don't fill cell or delay when gathering enough to fill cell. And the ATM protocol state is shown on the slide. The ATM adaptation layer, ATM layer, and the physical layer are all corresponding to the data link and the physical layer in OS reference model. As for 85 adaptation layer, originally there are 4 AARS: connection-oriented constant bit rate, CO variable bit rate, CO VBR merged with AAR4, 3 counters a connection as VBR. And the point of AAR5 is no silk encapsulation, and the packet level CRC can detect with high probability of errors. Then ATM seal structure is on the slides. Virtual path identify, virtual channel identify, payload indicator, seal loss priority, header error correction. Next is a virtual channel and a virtual path. Virtual channels identify individual flows of information between endpoints. Multitudes of flows through networks call switches inefficient for call switches to handle individual flows. Virtual path is an aggregation of virtual channels. And the second part is the main for PRS. Multiple label switching is a type of data carrying technique for high performance telecommunication networks. MPRS directs data from one network mode to the next based on short path labels, rather than long network address, avoiding complex lookups in a routing table. Compared with ATM, the similarities are label switching hierarchy of labels. The difference are packets have variable lengths. Routing can be done using established IB protocols. And some MPLS terminologies are label edge router, label switched router, label distribution protocol, label switched path, forwarding equivalence class. And then move to the MPLS label stack entries. Packet can have multiple labels. Labels can be pushed onto the stack, and labels are popped off the stack by ingress routers. The last label indicates protocols. So as shown on the slide is about pushing and popping multiple labels. Pushes on label as packets enter. The label is used for switching within this network. Pops of label as packets depart. The key points of the third part is interserve, which offer two types of service: guaranteed service and control load service, um, which designed to be separated from the routing protocol, which simplified RSVP, allowing operate with existing routing protocols may hinder ability to provide QoS guarantees. It can use soft state and designed to support group communication, which receiver oriented reflection of soft state reflex updates, reservation for sessions. And the message type as shown on the slides. The path means gathering information about the path from source. The reserves means reserving resource, and the TR is releasing resource before soft states timeout, and the arrow is arrow interpreting message. And the terminology of the diffserve is per hop behavior defines the behavior of a switch when forwarding certain packets. Behavior aggregate a group of packet passing through a common network point that have a common label, and a different service code point is replacing IPTOS field. And the different instance is domains, boundary node, entering nodes. So the last table is tying them all together to compare their relationship. So thanks for the listening.